All right, so I'm going to try something different for this video and use kind of a bigger cursor just so I can point at what I'm talking about, and hopefully that'll help a little bit. So this first free response question, we have a particle that's moving along a straight line, and we're given the velocity. This is very standard. And we also know that s of 0 is 10. This is probably for another chapter where we have to take the integral. So for right now, the only question we have is find all of the intervals where the speed of the particle is 2. This is a little bit different, finding the speed. And so what you need to remember is that speed is just the absolute value of velocity. So we're setting the absolute value of velocity equal to 2. You can just do this on your calculator, the solve button, and we're going to put the velocity formula in absolute values. That's in the same button category as the derivative and the integral symbols. It's just above. I think it's in the top right. And then we do equals to 2, comma t. Then outside, make sure we add our interval. And we get two answers, 3.12 and 3.47. Okay, next up, we have another particle question. Again, we're given velocity. This is a non-calculator question. And we're told, or we're asked to find when the particle is moving to the left. So moving to the left, we need to connect that with v of t is less than 0. Right, we're going to make that connection. That's v of t is less than 0 when we're moving to the left. Okay, and so with that, and actually I think I can do this as well. That works too. So we're going to do v of t equal to 0. Right, cosine of pi over 6t equals to 0. And so we need to do the inverse cosine of both sides, right? We're trying to solve for pi over 6. So that'll cancel. And so we get pi over 6, t equals, now cosine of t is equal to 0 at pi over 2 and 3 pi over 2. You can look at your unit circle. Those are when cosine is 0. So we want to basically kind of write these separately. Pi over 6t equals pi over 2, or pi over 6 equals 3 pi over 2. The pi's will cancel out, and we can multiply both sides by 6. We'll get t equals 3 or 9. Then we'll do a number line analysis. I just plugged into the first one, so I just kind of picked something between 0 and 3. I want to plug in something that I know. So I plugged in pi over 6, right? You could have plugged in anything, but I plugged in pi over 6. And so, sorry, I plugged in 1. 1 gave me pi over 6, right? Because it's pi over 6t. So I plugged in like t equals 1 as my test point so that I would be evaluating at pi over 6. All right, pi over 6 is in this first, right? Like all students take calculus. So it's in this first quadrant where cosine is positive. I don't need to plug in the other ones because I know that it's going to just switch back and forth, positive, negative, positive. So the particle moves left for 3 is less than t is less than 9 because v of t is less than 0 for that interval. Next up, we have another particle question, and this time we're given both v of t and a of t. And we're asked, is the speed increasing or decreasing? So we're going to just evaluate v of 5.5. You need to write what I have in blue down. If you only wrote that sentence, you're not going to get full credit. You need to show them that you typed this in, right? They can't see what you did in your calculator. So this here absolutely needs to be on your page. You will lose points on the free response if it's not on your page. Okay, next up, we have this question that is similar to the one that we did in class together, but I think it's a very, very important question, and that's explaining IVT and MVT. So for A, it says explain why there must be a value r such that h of r equals -5. So h of r, right, is IVT. Even if it's h of r equals 0, it's IVT because it's h, right? It's not h prime. So the way that you want to do IVT, always write this first line, which is basically stating it's differentiable, so it's continuous, so IVT applies. Now, we want to show that h is differentiable. So I just said both f and g are differentiable, and that means h is differentiable, which means h is continuous, so we can do IVT. Whenever you're doing IVT, you always just do you just plug in both endpoints. Okay, so if you need to kind of make yourself a note, whenever you're doing IVT, you plug in both endpoints. And then you basically write something like, basically like f of a is less than f of c, that middle one, which is less than f of b, the ending one. Whenever we're doing MVT or rolls, that's where instead of plugging in the endpoints, you're going to take the derivative, and you're going to set the derivative equal to f of b minus f of a over b minus a, or for rolls, you'll do the derivative equal to 0. Right, and on rolls, you had to show that f of a, the endpoints were equal, so you did have to plug in the endpoints on rolls. Okay, so anyways, for IVT, that's what we're going to do. We're just going to plug in our endpoints. So h of 1 is f of g of 1 minus 6. And so f of g of 1 is 2. So f of 2 is 9. So 9 minus 6 gives us 3. We'll do the same thing for h of 3. F of g of 3 is 4. Right, g of 3 here is 4. And so then f of 4 is negative 1. Negative 1 minus 6 gives us negative 7. So we wanted to know, is negative 5, must there be a negative 5? Well, negative 7 is less than negative 5, which is less than 3. You also may want to write this instead as like h of 3 is less than negative 5, which is less than h of 1. We're kind of showing that the negative 5 is in between our two endpoints. And so then we just say by IVT, and I usually just copy this. There must be a value r. I kind of wrote this backwards, but you could just copy this. There must be a value r for 1 less than r less than 3, such that h of r equals negative 5. I switched the order, not a big deal, but you can literally just copy what they have. For b, explain why there must be a value where h prime of c equals negative 5. Well, h prime of c, that's going to be MVT, right? It would have been rolls if it was h prime to 0. So on MVT, what we do is, we're going to state, I didn't restate this because we already had it. F of g is differentiable, but you could have restated that. You could have said h is differentiable, so it's continuous. So MVT applies. If you want to just restate that just to be safe, you can. All right, so then we're going to apply MVT, h prime of c equals h of 3 minus h of 1 over 3 minus 1. So h prime of c, h of 3 we already did, right? That's what we did right here. We got h of 3 was negative 7, minus h of 1 we had was 3, and then 3 minus 1 is 2. So negative 7 minus 3 is negative 10. Negative 10 divided by 2 is negative 5. So therefore, yes, by MVT, there must be an h prime of c equal to negative 5 for 1 less than c less than 3. Okay, next up, this is a calculator question. And it's another particle motion question. We're given the velocity again. And in what direction is the particle moving at time 1.5? So for directions, right, we always want to basically, do v of t. Right, if v of t is positive, then we're moving to the right, or in this case, up. And if v of t is negative, then we're moving to the left, or in this case, down. And if v of t is 0, then we're at rest. So we're going to just plug in 1.5 directly into v of t. We don't have to take a derivative because we already have v of t. So in our calculator, I just showed it being evaluated, but you need to write that line down. That's very important. We can't see what you typed in your calculator. And then you say particles moving up at time 1.5 because v of 1.5 was greater than 0. Again, it says why, so we need to write that sentence. We need to have that justification because the velocity was positive. B says find the acceleration of the particle. So again, we just, I did it this way. So I just did d dt of t sine squared of t squared. Make sure that everything matches up, that they're all t's. And then make sure that this at goes outside of the parentheses, at the very end, outside of the parentheses. So we get our answer, right? Just write that down. And then the velocity of the particle is decreasing, right? So they said, is the velocity of the particle increasing or decreasing? Well, the velocity is decreasing because a of 1.5 is less than 0, right? Acceleration means the increasing or decreasing of velocity. It's the concavity for position, right? So like if we kind of think of our position, velocity, acceleration, well, this is a derivative, and this is a derivative. Really, I should do with respect to time. And so that means like velocity is the, basically is if the position is increasing or decreasing. And a lot of times we say that by, moving left or moving right. That's the layman's terms for that. And acceleration is if the velocity is increasing or decreasing, but it's also from the position. We could jump from the position, we could jump straight to acceleration by doing the second derivative. So the second derivative deals with concavity, so it's also, if the position is concave up or concave down, which would kind of mean is increasing or decreasing at an increasing or decreasing rate, right? Because it's the rate of the rate. So that's kind of everything you would ever want to know about that. Okay, this one we did in class. I'm going to go over it as well, just so that you have it in video if you want to review it. But we'll do it quickly. So this first one, we see f prime of c equal to -1. It's a number, so that's MVT. And so we're just going to state that it's differentiable, meaning it was continuous. So we just literally do MVT. F prime of c equals f of b minus f of a over b minus a. F of 5 we were given was 2. So 2 minus f of 2 we were given was 5. And then I just moved over here. 2 minus 5 is -3 over 3. F prime of c equals -1. And then here I literally just wrote exactly word for word what they had here. There must be a value c for 2 less than c less than 5 such that f prime of c equals -1. Okay, B, show that g prime of 2 equals g prime of 5, and use this result to explain why g double prime of k equals 0. This is Rolls. I know it's g double prime of k, but think, what were the givens here? They were starting us off with g prime. So to go from g prime to g double prime, that's, a derivative. So when we set the derivative equal to 0, that's when we're talking about Rolls. Okay, if you had done MVT and just shown that the numerator went to 0, that could have worked as well, but Rolls is a little bit of a more direct approach. So first, because we're asked for g prime of x, we need to figure out what g prime of x is. So g of x was f of x, so this is chain rule, like the outside, derive the outside, and then leave f of x alone, and then times f prime of x, the chain of it. So we're going to do g prime of 2. That's f prime of f of 2 times f prime of 2. We can evaluate f prime of 2, that's 5. So we get f prime of 5 times f prime of 2. We have to stop there because we don't know anything about f prime. But let's try g prime. So g prime of 5 equals f prime of f of 5, right, f of x, times f prime of 5, right, we're plugging in for x. And again, we can plug in f of 5 is 2. So you get f prime of 2 times f prime of 5. You'll notice those are exactly the same. They're switched, but they're the exact same thing. They're equal. So g is differentiable, it's continuous, and g prime is equal to g prime. G prime of 2 is equal to g prime of 5. That's all of the conditions for Rolls' theorem. So by Rolls' theorem, there must be a k for 2 less than k less than 5 such that g double prime of k equals 0. Like I said, if you wanted to do MVT, you could, but then you would have needed to show like the subtracting and that became 0 in the numerator, and that could have worked. But this is the most direct approach. Okay, C is a little bit funky, but D is definitely easy. So this is one of those cases where, if you get stuck on C, don't just abandon the problem, move on to D, because you could probably get D right. But going through C, it says show that if f double prime of x equals 0, then the graph would not have an inflection point. So for inflection points for g, we have to take the second root. So we're going to do g double prime of x. Now I have this formula up here. This is going to be, to take the derivative of this, is going to be product rule. So the derivative of the first, the outside is f prime. So that becomes f double prime. Then we leave the inside alone. Chain rule times the derivative of the inside is f prime of x. Then this second term, f prime of x, we're going to leave alone. Then plus, now the first term we leave alone, and the derivative of f prime of x becomes f double prime of x. So now if f double prime of x is 0, then we're going to just put anywhere we see the f double prime, we're going to put 0, right? Because it's 0 for all values. So 0 times anything is 0, plus, and then over here we get times 0, 0 times anything is 0. So g double prime of x would be 0 for all x's. That means g double prime of x is never going to change signs because it's always 0. So there would be no inflection points. Okay, this would be full credit. There is another explanation. It's actually a little bit quicker, but it's kind of hard to think about. But basically, the way this explanation, I put this in green, works is, basically if f double prime of x is positive, we're concave up. If f double prime of x is negative, we're concave down. But what about f double prime of x equals 0? We don't really talk about this as much, but when f double prime of x is 0, our graph is actually linear. It's neither concave up nor down, it's linear. And so if f double prime of x was 0, that means that f of x is linear. And that would mean that f g of x, like f of x, this is linear. If we plug something linear into something else linear, it'll stay linear. So g of x will also be linear. So if g of x is always linear, it's never going to have an inflection point, right? Like straight lines, they don't have any concavity, so they don't have any inflection points. So you could have actually written this out, but it's kind of tricky. Okay, and then the last one I think is totally something we should get a point on, or get all the points on, and that's explain why there must be. So we're thinking IVT, MVT, or rolls. We already did MVT and rolls, so we're probably thinking IVT. But then when we see just h of r, that confirms, yes, it's IVT. It's not h prime, it's just h. So they gave us this formula. So just like we did before, we want to do h of 2 and h of 5. Right? So we're going to first off just say, yes, this is differentiable, so it's continuous. And then we're going to plug in h of 2, right? So f of x becomes f of 2 minus x becomes 2. F of 2 is 5, 5 minus 2 is 3. Then plug in, f of 5 minus 5. F of 5 was 2, 2 minus 5 is negative 3. We wanted to know, is there an h of r equal to 0? So we're going to write negative 3 is less than 0, which is less than 3. Or you can write h of 2 less than 0, less than h of 5. It's probably best to write them both. And then we say by IVT, there must be a value r for 2 less than r less than 5, such that h of r equals 0. Okay, next one is a velocity question with a calculator. And part D on this was from chapter 6, but I threw this in here just kind of thinking ahead and getting prepared for tomorrow's lesson. So a particle moves along the axis, we're given a velocity, and we want to first find the acceleration. So in order to find the acceleration, nice and easy, we just take t of equal to 2 and we plug it into the derivative of velocity. So I wrote that a of 2 equals v prime of 2, and then on my calculator, I just plugged it in like that. And we just write our answer. There are no units here, so we don't report any units. B says, is the speed increasing or decreasing? We need to make sure that we write both of these, right? V of 2 equals, and I just evaluated it, right? I just took exactly what V was. We did on our calculator at time 2, and then we need to write it in, put less than 0. Then A of 2, just repeat it, less than 0. And then we're going to write out our sentence. The speed is increasing because v of 2 is less than 0 and a of 2 is less than 0. They have the same signs. I like to add the word same signs. Okay, C, find the time at which the particle reaches its highest point. Now, when we see highest point, we're thinking max. And how do we know if this was basically like absolute max or relative max? Well, technically this is like an absolute max. But we're going to do the same steps that we do with relative max. Because absolute max, we need to have an interval. We need to have an A and a B to do that chart. Otherwise, if we don't have an A and a B, we're always going to just do our number line. So the particle reaching its highest point, that's going to be like S prime of t equal to 0, right? The position equal to 0. And S prime or X prime is just V of t. So we're going to set V of t equal to 0. Okay. So I wrote that in, V of t equals 0. I didn't show that on my calculator, but it's just the solve button, right? You're just going to do solve parentheses and then type this in, equal to 0, comma t, close your parentheses, and then at time greater than or equal to 0. When you do that, you will get the answer 0.4430. And then we're going to make a number line for 0.4430 so we can justify it, right? We can't do the chart because we don't have endpoints. So we just do a number line. So we put in 0 on the left side because it's always greater than 0. Now, we already did plug in v of 2, right? Like we plugged in v of 2, we got a negative. So I can make this guy negative. And because it's we don't have any squareds, we can know that that's positive. But if you want to be extra safe, just I showed, we could plug in like 0.1 is in between 0 and 0.4, that's positive. So this means the particle reached its highest point at time 0.430 because it increased and then it decreased, right? It never did anything else. It increased, then it decreased. So this has to be the max. So just kind of state that in words, right? The particle reaches its highest point because v of t is greater than 0 for 0 less than t less than 0.430, and v of t is less than 0 for t is greater than 0.430. You're just basically stating your number line in words. it's not a relative max. So we don't want to, do our relative max of it just changed from increasing to decreasing there, because this is the only time it changes from increasing to decreasing. So we kind of want to try to make that clear. Okay, and then number 6 was find the position. Again, this is a intro to tomorrow's lesson, but position, velocity, acceleration. We're at velocity, and to go from velocity back to position, we take the integral. So our FTC formula here is that x of 2 will be equal to x of 0 plus 0 integral from 0 to 2. Right, the 2's match and the 0's match. Right, the one next to it's always the bottom one. Okay, x of 0 was given in the stem. If you reread the question, they tell you the position at time 0 was -1. And for the integral, we're just gonna, or actually I typed in that entire thing. So I typed that entire thing into my calculator. We got -1.3607. Then the follow-up question was, is the particle moving towards or away from the axis? So we're gonna do x of 2 is -1.3607. If you want to add, that's less than 0. And v of 2 is also less than 0. So if you memorize that, that's moving away from the origin. If you didn't memorize it, sometimes I'll just do like a number line with x. So here's my 0. My position is negative, so I'm going to put in like, here's the particle to the left of the origin. My velocity is 0, so it's moving to the left. So that shows moving away from 0. Right, and then number 6, actually, I didn't write this, but B and C are both chapter 6 topics. So definitely do A and D. If you want to get a head start on chapter 6, do B and C as well. And so this shows us a graph of G prime. A asks us to find all of the coordinates of inflection, or inflection points. So remember that, inflection points are when G double prime changes signs, or when G prime changes from increasing to decreasing, right? And this will also be like when G prime graph has a local max or min, or when G changes between concave up, concave down. So that's very important to know. This is something you may want to make a flashcard for. Like, those are all the different cases we have for concavity. Now, because we have the graph of G prime, that means we're going to be doing this one, when G prime changes between increasing and decreasing, or if it has a local extremum. So we can kind of see that this graph is increasing, right? G prime is increasing, G prime is increasing, G prime is decreasing, and G prime is increasing. So it changed at 4 and at 1. That's where it made the changes. Now, technically, -1 is also a possible inflection point. So if you want to write that, you can. So I kind of showing some like more work. You didn't have to really show all this work, but we'd have possible inflection points when G double prime is 0 or DNE. So that's at my corners. At -1, it makes a corner. At 1, it makes a corner. And at 4, it makes a corner. And then for like the G double prime, it's positive, like it's increasing, increasing, decreasing, and increasing. So plus, plus, minus, plus. And you can do that. You don't have to. The thing that we really need here is this. This is the important thing. So G has an inflection point at x equals 1 and x equals 4 because G prime changed between increasing and decreasing, or vice versa at these values. You could have also said, or, because G prime has a relative extremum. But make sure, it's very important, make sure that your answer has to do with G prime. If you say because G double prime changes between positive and negative, technically that's true, but you're not going to get this marked correctly because we don't have any information about G double prime. We don't have a graph of G double prime. We don't have an equation of G double prime. So you can't justify it by talking about G double prime. Same thing if you said because G changes from concave up and concave down, you're not going to get points because we don't have a graph of G. We don't know anything about G. We have a graph of G prime. Okay. B says find the absolute maximum. So our steps on this are to first set G prime equal to 0. That happens at x equals -1, 2, and 6, right? The zeros, -1, 2, and 6. And then we're going to make a chart. So our chart's going to have our endpoints, -3 and 7, and those critical points. Then we're going to just evaluate every single one of them. And the formula I used was basically the FTC formula, which is basically that I'll write it with f's. It works with g's too, but basically f of b is equal to f of a plus the integral from a to b of f prime of x dx. This is just rewriting FTC, right? FTC is the integral from a to b of f prime of x dx equals f of b minus f of a. All we're doing is we're just adding the f of a over to the other side. Okay, so that's the formula that I kind of used. So g of -3 equals g of 2. Why g of 2? Because that's what we were given. Right, so we were given g of 2 equals 5, so that's always going to be the other point we use in our integral, right? Integrals are going to need 2 endpoints. So we're always going to use 2 as our starting point, and then whatever other, x we have, or whatever other time. So I used from 2 to -3. Now be careful about this. 2 to -3 is going backwards on my graph. We're reading right to left, right? So that means when we do this with geometry, that's how we take the integral with the graph, is with geometry, area under the curve. We need to flip everything because we're reading backwards. So we're starting at 2. And I'm going to erase all this so we can kind of see that. So we're starting at 2, which is right here, and we're going back to -3. So we're going 2 backwards. So that means this area here normally would have been a positive area. That's going to turn into a negative area because we're going backwards. And this area here under the curve, this triangle, is going to be a positive because we're going backwards. So this first area is 1/2 base times height, right? 1/2 times 1, 2, 3 times 1. And this area is 1/2 times 2 times 4. But we'll have a negative and a positive for those triangles. So we're going to do that. 5 minus 1/2 times 3 times 1 plus 1/2 times 2 times 4. You simplify, you get 7.5, or you could add 15/2. Then we'll do it for g of -1. So the integral from 2 to -1. From 2 to -1, that's just that triangle. And again, we're going backwards, so it's going to be negative. So 5 minus 1/2 times 3 times 1, we get 3.5. Next, we have 2. We don't have to do an integral here because they gave it to us. It's just 5. Then next we have 6. G of 6 equals g of 2 plus integral from 2 to 6. So now we're reading left to right. So now we can just think about this normally. So now, right from 2 to 6, we're just going left to right. So this is below the axis, so it's negative. So it's negative, and then 1/2 times 1, 2, 3, 4 is the base, 2 is the height. So 5 minus 1/2 times 4 times 2. Okay, you can put the minus here. I don't like to put it with the height because like when we do pi r squared, the squareds will turn positive. So I usually do the minuses outside. So this is 5 minus 4, we get 1. And finally, g of 7. Right, one way you could do this is like realize, okay, we're at 1 here, so it's 1 plus the area of this guy, which is 1/2, so it's 1.5. Or you could do the whole integral, which is what I showed. 5 minus, g of 2 plus the integral from 2 to, this should have been a 7. I have that as a 6, that should have been a 7. Right, and so we get 1.5. All right, now the absolute maximum in this is the 7.5. That's our biggest number. So we're going to write this in a sentence. The absolute max is 7.5 at x equals -3. Okay, next up, it says find the average rate of change of g of x. So average rate of change of g of x, the formula will be g of 7 minus g of -3 over 7 minus -3. And we just got those values in part C. So if we did part C correctly, we just go and grab them. G of 7 was 1.5. G of -3 was 7.5. So it's 1.5 minus 7.5. That's -6 over 10, which is -3/5. And then after that, they ask us, find the average rate of change of g prime of x. And then does the mean value theorem in this interval guarantee a value of c such that g double prime would be equal to this average rate of change? So our average rate of g prime of x will be g prime of 7 minus g prime of 3, right? For g of x, it was g of 7. For g prime, it's g prime. G prime of 7 is from our graph. So we're going to just go up on our graph. And on our graph, right, g prime of 7, since this is the G prime graph, will be the y value, will be 1. And G prime of negative 3 will be the y value, will be negative 4. So this is going to be 1 minus negative 4 over 10. You get 1/2. So what they're asking is there guaranteed to be a value G prime of C equal to 1/2? Now, what are our conditions for mean value theorem? The graph needs to be continuous, G double prime equal to 1/2. So the conditions for MVT are that our graph needs to be continuous and differentiable. Well, G prime is continuous, the graph is continuous, but it's not differentiable, right? When we look at this graph, we have several corners, 1, 2, 3 corners. So we have 3 points where G prime was not differentiable. So that actually means that no, the mean value theorem would not apply because G prime of X is not differentiable for the interval from negative 3 to 7. If you want to explain that further, right, it's not differentiable at negative 1, 1, and 4 because that's where the graph of G prime makes a corner. Right? So hopefully that kind of makes sense for you guys. If you have any questions, please feel free to email me, and I will get back to you as soon as I can, or post them on the Google Classroom, or even message Kyra. And good luck studying, and I will see you on the next one.